So the first one is y equals x squared plus 1. It's a parabola. And the next one is y equals 2, horizontal line. And the x-axis. The x-axis, what's the other name of the x-axis? What's the equation of the x-axis? Y equals 0. You don't have to graph y equals 0 like I did, but I just do that so that it'll show up. It'll stand out on my graph. Okay? And then you're going to go to, make this a little bigger. So then you're going to go to up to graph. This is what we're drawing. Now, if you want to zoom in or zoom out, plus zooms in, minus zooms out. Okay. So this is in between the blue line and the red. That's the shaded area. Okay, that's the part that's going to revolve around the x-axis. Okay, so give yourself a good picture there. And then label those so you know which one was x squared plus 1. X squared plus 1 is a parabola. There's only one parabola and 2 lines. So let's see. I'll just use colors. Let's see here. Let's see. This one was red. Blue is y equals 2, and green is the x-axis. Okay. And then the shaded region was, even though we're not finding area like we were doing before break, there's an area. This is the area that's going to revolve around the x-axis. And it'll create the 3D shape, kind of like how I showed you on that YouTube slide or that YouTube clip. Okay. Okay, so first thing, is it a dx or dy? Dx. Because it's revolving about the x-axis, and the x-axis is a horizontal line, okay? So dx, okay. So the first thing we're going to do is identify what big R and what little r are. Big R is the radius. The big radius, the one that goes from the edge to the center, and little r is the one that goes from the missing part, okay? First of all, this kind of looks like a problem we did yesterday, right? How do I know disk method won't work? Because look at the shaded region. Is the shaded region touching the axis of revolution at all? What's the axis of revolution? The green, right? Is the shaded region touching it at all? No. So if it doesn't touch, it's going to create an emptiness, an empty part. That's where we need big R and little r. Okay, so this is definitely a washer problem. Okay, if you go through the ones we did yesterday, it always touched. Like yesterday, if I would have changed this problem to about the line y equals 2, and it revolved around that, that would be a washer problem, or that'd be a disk problem, right? Okay, so here we go, big R. Big R extends from the top, or so what I do is it extends from here, and I'm gonna go down until I get to the axis of revolution, which is here. That's big R. Little r goes from, it doesn't start all the way at the top. It starts from where the shaded part ends. So like right here. And it extends all the way down to the axis of revolution. So in other words, big R extends from the outer boundary to the axis of revolution. Little r goes from the inner boundary to the axis of revolution. Okay, that's how you draw those lines. Why do I draw the lines? Because it helps me identify what big R and little r, because I'm going to subtract dot minus dot for big R. Okay? So for big R, what is the top dot? Where is the top dot on? Y equals 2, right? Y equals 2, so we just put 2 minus, where is the second dot at? 0, right? Y equals 0. So it's just going to be 2 minus 0. Okay? Little r doesn't start at 2. It starts at x squared plus 1, right? So it's going to be x squared plus 1 minus, where does it end? 0. They should both end at the same spot because they're both going to the axis of revolution. So once you do that, you're ready to write the formula and then use the calculator, right? So volume equals, always got to include a pi there because it's circles. Bounds, we'll worry about the bounds in a second, but let's write what we have. So big R. Big R is just 2 minus 0. 2. Squared. Because that's part of the formula. Minus, or just 4. You can write 4 in there as well. X squared plus 1 minus 0. Just x squared plus 1. Squared dx. Don't forget about those squareds, because big R is squared and little r is always squared. Just like yesterday. Right? Radius squared, pi r squared, circles, that's why the radii are always squared. Okay? Bounds. Bounds. So left and right bounds. So in other words, where are the left and right bounds for the shaded part? So which x values is this guy here? -1, right? And if you didn't know, you can use the calculator to figure it out. And then this guy over here is +1, x equals +1. So it would be -1, to +1. And once you get there, you got enough for the calculator to answer the question. So verify that you get 13.404 rounded. When you type it in the calculator, I like to simplify, so you don't have to put 2 squared. You can put 4, because 2 squared is 4. So you could put 4 minus this guy here. Don't forget about the pi. Either include it in your formula when you're typing it, or multiply by pi after. Some people don't want to worry about the pi until they want to do the integral first and then multiply times pi. Go for it. Some people want to put it in there from the beginning. Whichever you choose, just make sure you don't forget about it. Okay? So this pink area would revolve around. Okay? What type of shape would it make? If you can visualize it, great, but don't worry about visualizing it. It's not important to see the shape. Some of so one of the last things to develop in your brain is visualization, spatial visualization, where you can see things without seeing them, right? You can visualize it in your head. So some people can see, oh yeah, it's going to be like this. Some people are like, I have no idea what it's okay. That's why they don't ask you to visualize it in your head. They just say, find the volume of it, okay? So don't worry about, I don't know what shape it would make. They're never going to ask you what shape it is. Don't worry about what shape it would be called or whatever. Is it a donut? Would it look like one of these guys that we have up here? Don't worry about it. Okay. Okay, so let's go to number 2. So number 2 is very similar. The only difference is it's not the y-axis anymore, right? Or it's not the x-axis anymore, right? It's y equals -1. have to re-put everything in. Let's see. So it's x squared plus 1. Y equals 2. And then not y equals 0 anymore, it's y equals negative 1. But the picture is going to look almost identical. Just the green is going to be a little farther down. Shaded area is the same. So give yourself a decent picture so you can so you don't have to visualize all these things. You already have to visualize enough. You don't want to have to do more than that, especially when you can use your calculator. Can you do it without a picture? Yes. But why would you want to when you have a calculator in your hand? And it takes you a minute to type it and draw it, sketch it. When you're doing this, when you get good at it, you can do it just straight from your calculator. Like you can see it straight from your calculator and you can say, oh, okay, so big R goes from here to here, little r goes from here to here. But for right now, it's in your notes. Here is the part that's going to revolve around. Now it's not revolving around the x-axis anymore. It's revolving around y equals negative 1. Y equals negative 1 is still a horizontal line, though. So it's still going to be dx. And this guy right here is y equals x squared plus 1. Okay. Okay, so outer boundary. So which one, how do you know where the outer boundary is? Well, look where the axis of revolution is. The green is the axis of revolution. So the outer boundary is going to be above, up, okay? So we go here, and then you draw a straight line down. That's big R. Little r is outer boundary. So in this case, it's below. And okay. Formula? V equals pi. Looks like our integral boundaries are the same, right? -1 to +1, because it's the same shaded area. Okay, so we got a big R squared minus a little r squared dx. Okay, so big R goes from y equals 2 down to y equals -1. So we're going to say 2 minus -1, or 3. It simplifies to be 3. Little r goes from y equals x squared plus 1 down to y equals -1. So x squared plus 1 minus, right, because it's, minus -1, yeah. So in other words, plus 1. So we got some double negatives there. So when you put it in your calculator, you want to simplify it as far as you can, because sometimes the calculator doesn't like some of those double negatives and stuff. So this would be 3 squared, or 9, right? Minus x squared plus 2 squared. Okay. When you plug that into your calculator, verify that you can get this, 21.782. Okay. Why is it washer method? Because again, is the shaded area touching the axis of revolution? No, there's a big gap in there. If there's a gap, it's going to be washer for sure. If there is no gap, You can use disk, but you can also still use washer. We could use, like I said, yesterday, all those problems that we did, you could still use washer, just there would be no little r. Little r would just be 0. Okay? All right, so if you haven't already, give yourself a picture here. Okay. So we have e to the x. Oops, no, I don't want that. We have e to the x. We have y equals -2. And we have two vertical lines. X equals 0, x equals +2. So I'm going to go to my templates, go down to where it says x equals 0. +2. And then it's going to revolve around the line y equals -4. I'm just going to throw that on there too because that's important. So it's not going to be part of the shaded part, but it's going to be part of an important part of this. Okay. I'm going to zoom out a little bit. Let me navigate up a little bit. So a lot of stuff going on. One curve, 1, 2, 3, 4 lines. Okay. Okay, so let's label these to see what's what. So the curve is the easiest one because that is y equals e to the x. That's the curve, it's exponential. The green is the y-axis, which is x equals 0. The orange is also vertical, so that's x equals 2. The blue on mine is y equals -2, and then the kind of pink, purple is the axis of revolution. So a lot of stuff going on there. So now I have to figure out where the shaded part is. Well, let's see. Bounded, R is bounded by the curve, the red, by y equals -2, the blue, and then the two vertical lines. So it's going to be this area here. That's going to be the shaded part, the R. It doesn't extend down to y equals -4. That's where it's revolving around. Okay. All right. Hey. Thanks.
Thank you.
All right. So now, is this a dx or a dy? Is it revolving around a horizontal line or is it revolving around a vertical line? It's still horizontal, right? About y equals -4, so it's revolving around that kind of the peak line, that neon pink line. So it is still dx. Okay. So it's revolving around. And that shaded part is not touching that pink line there. So that means it's definitely going to be a washer. We're going to have a big R, we're going to have a little r. Okay. All right, so let's set this up. Volume equals pi. I'm not worried about the integral bounds right now. I'll come back to that. Big R minus little r dx. Okay, so here we go. Big R. Big R goes from the outer. So sometimes it's easier to start with the axis of revolution. I've been going top to bottom, but sometimes it's easier to go bottom to top because you always start at the axis of revolution. And then you go up until you're not in the shaded part. Okay? So watch. If you're not sure, watch what I do. So start here, and then go up until you're not in the shaded part anymore. Make a dot. That's going to be big R. Little r starts at the same line and goes up until you hit the shaded part. That might be easier for you to... Okay, so big R, we go top dot minus bottom dot. So the top dot is at that curve, e to the x, right? Bottom dot is -4. So it's going to be e to the x minus -4, or plus 4. Okay. Little r. Top dot is at y equals -2, so it's going to be -2 minus -4. Again, both of those are just plus plus because they're both double negatives. So it's really e to the x plus 4 squared minus 2 squared. Okay. Now let's go back to the shaded area. The shaded area, where is the left bound for the shaded area? X equals what? 0, right? X equals 0. And then the right is x equals 2. So the bounds, the integral bounds, are from 0 to 2. Okay. So let's see, verify that you're going to get 320.164. 320.164. Okay. Okay. What time we got? Okay, so we'll probably do 2 more problems and then tomorrow. So today we'll focus on all of the dx problems. Tomorrow we'll do the dy problems. Okay? So we have 1 more dx problem. That's example number 4. Or we have 2 more dx problems, sorry. So example number 4. So let's do example number 4. So give yourself a picture. So sketch that example number 4. I'll give you a few minutes to sketch the picture. It's a dx because y equals 6 is a horizontal line. So sometimes this might happen to you. I'm just bringing it up because it happened to me, where the axes, look at the axes, the x and the y, they're huge, 100, 200, 300, 400, it might be even thousands. That sometimes you're like, why did it give me that? I don't want those big of values, right? How do I reset it? Reset it, just go to auto. See where it says auto right above it? If you hit auto, why did it do that? Let's see. Yes. So I want to zoom in like quite a bit. Let me go back. I don't know why it's giving me such huge numbers. Unless I put something in wrong. Oh, not 2x. 2. Okay. So the shaded area is going to be where they all kind of intersect right there. So.
You can go to one of the dots.
You can go to one of those.
Oh, can you?
Yeah, if you go to the dots and press zoom in, it'll zoom around the dot.
Oh. So I don't want that
So you
dot.
don't gotta be.
So I want to zoom in like over here, right? Oops, not over there.
No, one of the
No, the
intersections.
actual dot.
The black ones. And then you just zoom in.
Yeah, pretty much.
Okay. And then zoom in.
Yeah.
Oh, okay. It'll like.
There we go.
There you go.
Yeah.
Okay. Navigate.
You guys look over.
I also know what he means.
I didn't look over.
Okay, so there's the shaded area there. That in between the red and the blue is the shaded. Is going to be where the shaded part is.
What an interesting 0.145.
Okay. 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 So the shaded part, so R is determined by the red and the blue. The green is just where it revolves around. Okay, so that's how you kind of know where is the shaded part. It's right here, this little sliver here. Okay. So we have y equals 6. We have the red is the natural log of x, and the blue is y equals 1/2 x plus 2. Okay. All right. So that little shaded part is going to revolve around the green. There's a big distance between the revolution, the line of revolution, axis of revolution, and the shaded part. So that's washer. Okay. Okay, so I'm going to start. So this time I'll start. So this time the axis of revolution is above. Usually every single problem we've seen today, the axis of revolution was always below the shaded part. This one is above. It's going to be the same thing though. It's going to be the same thing. So I'm going to make a dot on the axis of revolution. This time though, I'm not going to go up. I'm going to go down because that's where the shaded part is. And I'm going to go down until I leave the shaded part. Okay? So I go down, down, down. I enter the shaded part. Now I'm leaving here. That's where I'm going to make my second dot. So that's big R. I'm going to make another dot on the shaded area right next to it. And I'm going to go down until I get to the shaded area. But I'm not going to go through like I did the last one. I'm going to stop there. That's little r. When I set up my formula, it's still going to be big R, or top dot minus bottom dot. Okay, that's still going to be that. So we got, let's see, volume equals pi. And then we have big R minus little r squared. So big R is big R goes from y equals 6, so 6 to y equals 1/2 x plus 2.
Wouldn't you do the other way?
Say it again.
Wouldn't you do the 1 half x plus 2 minus 6?
No, we always go top minus bottom. Yeah, we always go top minus bottom. Great question. Yeah, great question. So we always go top dot minus bottom dot. So even if the axis of symmetry or the axis of revolution, is above, you still go top minus bottom. Yeah, great question. Great question. Because this one is different. Okay? So we go 6 minus, I'm subtracting 2 terms. So I'm going to put those in parentheses. I'm not just subtracting 1/2 x. I'm subtracting 2 as well. So 1/2 x plus 2. You can distribute the negative if you want to make it negative 1/2 x minus 2. That's fine. Or you can leave it in parentheses.
Minus 2.
Minus 2, minus 2. It is minus 2. Okay, so the graph was right. What I wrote down was wrong. Yeah, definitely important. Little r goes from 6 to the red, which is natural log of x. So it's going to be 6 minus the natural log of x. Dx, we said. Now the bounds. The bounds, the left bound and the right bound. So the bounds here and here, right? Those are the bounds. So I got to figure out where those x bounds are. And it doesn't look like it's a whole number. It looks like it's kind of in between. So you go to your calculator and figure out where's the intersection. Where does the red and the blue intersect the first time and the second time?
We figured out it's the same even if we do the other way.
Oh, it comes out the same?
Yeah.
Didn't know that. Yeah. So that's good to know. So order doesn't matter, yeah. Because you're squaring it, right? Is that why?
Maybe.
Makes sense, yeah.
Good. Yeah, good. I didn't know that. Yeah. I didn't know like order didn't matter for that. That's good. That's good to know. So even if you do kind of make a mistake or you don't remember, you just remember subtract the 2 and square it. Yep. Did you get 312.752?
Yeah.
Yeah.
And we did both ways.
Both ways it worked? Good. Okay, so the first, that guy right here is going to be when x equals 0.1456. So just in case you forgot, let me go back. Oh man, it's going to erase all my stuff, isn't it? Yeah. But I'll show you how to do it. So you just go to graph. Mine's not going to have anything because it erased my graphs, but it's going to pick a graph And then you're going to hit calculate. It'll be a calculate down here. And then you calculate, pick a graph. It doesn't matter which one it is. And then say intersection. And then it'll go through and it'll allow you to do intersections. If you don't remember how to do it, I can show you that on the calculator later, how to do intersections. But yeah. Okay. So the first intersection is at 0.1456, and the next one's at 8.2109. Then when you put that all in, you get 312, approximately 312.752. Okay. All right, so the last one we're going to do, and I'm going to let you guys do this one because it's a good practice, is 6A. Do 6A.
Yeah, because that's the last one. That's no, that's the last one.
Yeah, because number 5 is revolving the other way, which we'll do tomorrow. 6B is the same thing. So do 6A. 6A.
So guys, right here, it works. So okay, so we're just rotating the x-axis. We should use this.